Hey guys, Stephen here from Heresy Academy. So this is the video where we're going to put the code, our script, onto our projectile that we made, and then we'll make it so not on our projectile, on our slingshot, and then we'll be able to fire it along. It'll hit these, and it'll knock them over. Once we do this part, it will hit these, it will knock them over. It won't have the complete desired effect because we won't be coding this stuff until the next video. Before I do that though, I do want to point out this level platform. I've added an edge collider, as you can see this green line as I'm zooming in. I've added an edge collider here because, well, I forgot to in the last video. I might have mentioned it, so if you are following the video and trying to recreate this, then it's advisable to add this edge collider. Otherwise, what's it called? When you click play, everything will fall down. Of course, you can put a box collider. I think I might have mentioned that as well. You could put a box collider on it. So I'll just quickly do this. Go to Physics 2D, add box collider. The size. I'll just change the size so it's like, basically the size of these. What's it called? The platform itself. Change the Y size so it's like that big. Change the offset so it's a bit further up. I mean, you will still want to tweak it a bit more, make sure that like it fits around it. Just do that just to give it more of a solid platform. So if you hit this, it bounce off. But then if you go underneath, it'll miss sort of thing. So you can still hit these without that. But I'm just doing it with an edge collider. So I'll remove that component. I just wanted to show you how to set it up. So I'm just having that edge as a solid object. So what we're going to do, if you go to our projectile here, we're going to add a component, and it's going to be a new script. It's going to be a C# script, although you could do a JavaScript. You used to be able to do other scripts. I don't know if you still can, but we're just working with C#. We'll just call this projectile. It's going to be added to the projectile. It's a script for the projectile, and this will work with whatever projectile you want to use. Although, a point to make, there will be a part of this script where we declare a circle collider. So if you use a different shaped projectile, you have to make sure you use the same sort of collider there, otherwise it won't work. So I'll point that out again as we actually write that line. So I'm going to open this up. It'll go in mono develop, which I've not even got open, so it may take a few seconds to open. Maybe it won't even work, who knows. So let's talk through a few things we're going to do. Actually, let's go over to the slingshot. I just want to check. Yeah. I realised I probably made a mistake with my line renderer, because I put a line renderer on the projectile even though it's supposed to go on the slingshots. Don't know why I did that. But if we go to the slingshots, go to both of them, you can't edit them both at the same time, but you can still add line renderers. Then go to slingshot number 1. So just to zoom in, the first slingshot is the back one. So this is where I'd mentioned you put like your starting width to be 0.15 and then the end width to be 0.16, and then for the forearm, put them both at 0.17, just because like this is the front end, and the reason you make this one end at 0.17 is just so it gives that slight tiny effect of it getting bigger as it's sort of getting closer to like the front position. And obviously using hand gestures there did absolutely no good. So drop down to the materials, and the new material, which we should have given it a name, I don't know why I didn't, so Slingshot Black. You can obviously, I think I mentioned when we actually made the material, you can use any sort of shader, add any textures you want, stuff like that. That's completely for you to completely change the design of. Thinking perhaps maybe you don't even need a line renderer, because all it is is just for visual impact. So we're using a slingshot that has 2 lines coming out of it. If you were to use an actual catapult or a trebuchet, the thing they used in the old days, or a cannon, things like that, the setup will be a bit different, and this is just for a slingshot. So if you did have any requests, if you wanted to know how to make all of this sort of stuff work with a cannon or an actual catapult, or like I said, that trebuchet, the weird French name thing, I think it's French. Anyway, yeah, sorry about that. So go back to your line renderer on the slingshot, and you'll drag your material over where it says element 0, and the same for this one. This is just going to, when we render our line, it will make it black. So model developer is ready now, but just before I do that then, if you are following along this video as close as you can, make sure you put your edge collider on this platform here, just underneath these, or a box collider, or some form of collider. Otherwise, when you click play, these will just fall down and it'll just ruin your day. I don't know if I did that one on video as well, because after the video I went through to check things, I was like, oh no, I forgot to do that. But I think I did this one during the video, so just the same way as doing that one. And then obviously, again, if you followed it, and for some reason I put the line renderer on here, you're supposed to put the spring joint, and that is correct. Maybe I just put it on there just to show how to set it up. I can't remember why I would do that. So make sure you put 2 line renderers, one on the front, one on the back part of the slingshot, one on the front part of the slingshot, and we'll just call this back arm, just to name it. What I will do as well is I will make another empty game object, open the transform, reset it to 0, and I'm going to call it slingshot. Now, this may seem to be like a completely weird thing to do. I'm going to drag it onto there, drag the slingshot to level 1, go back and save level 1, make sure everything's cool. Then for the slingshot, then you open it up, you've got slingshot back arm, forearm. I'm going to go down to the prefabs folder, and I'm going to create a slingshot prefab. Now, the reason I'm doing this is if we go to our slingshot, it'll be easy this way. Open the sprite renderer and just find the catapult sprite. And then I'll open it in the sprite editor. As you'll notice, we've changed the origin point, so I might even move that a bit closer to the edge. And then same for this one. So if you are going to do multiple level designs, when you change the position of your catapult and your catapult sprites, the transform.position works from this origin point here, or this pivot as it's called over here. So if you thought that position here, let's say it was 5 by 5, and you decide that's where you want the slingshot to be, it will actually put the pivot point at 5 to 5. So if you click on your slingshot, the minus 15 and then 18.63 is the pivot point of the slingshot. So I've made it as a prefab because in other levels we may put it back down here, and then what we'll do with that is we'll set the whole position of the prefab itself rather than try to change the slingshot pieces. Anyway, so that's just a bit more to the how we'd set it up. Just little bits and bobs that I might have forgotten in other videos. And to be honest with you, that may happen a fair bit. I may forget certain things, and then I'll come back and be like, right, okay, well, you need to do this, you need to do that, etc. What we could do doing as well is making a folder for scripts and putting the script in there. But I'll do that after I've written the script, just so, because Model Develop's working, if I change its position, it's in the directory, it might decide to crash on me. So it's going to be a decent script, so grab the popcorn. You can pause it and follow it along, but if you want, well, I'm never going to be able to check. I was going to say if you want to, I'll at the end of it, I'll just like hold the what's it called, the recording still, so that you can pause it and write it out, and I'll scroll down, hold it still, so you can pause it, rather than you keep trying to pause it and write it. Just because we are going to jump back and forth between a start update, the start, the update, what else? the actual declarations, the awake area. We're gonna put an awake in there. So I will jump back and forth between them. If you're doing it on, if you are writing it on the computer, then it's fine. You can just obviously change where you're writing your stuff and follow it along that way. But if you were, I know some people that do this. If you do sit there with a pen and paper and try and write the script out on pen and paper and then put it to computer later, it's not going to work because you'll just run out of space and end up confusing things, and then stuff might not work, and it just makes more work for yourself, really. So yeah, just grab the popcorn and enjoy. So I started out with making. I'm going to make a float and a reference to our two line renderers. The float that we're going to make, so I'm going to make a public object here, public float, and I'm going to call it stretch limit. It'll be completely useless at the moment. I'm going to just put this to 3F. It may not be enough, maybe want 5F, stuff like that. And what this will be is when we drag the projectile, so in this case it's the alien, for you it might be an actual ball or a cannonball, sort of anything, whatever we throw in the projectile. We don't want to just completely drag it everywhere around the map, because then you could just drag it over to what you're trying to destroy and just wobble it around until you knock everything over. Then you probably get like bonus points for not even firing. I don't know how that works. So we'll have a stretch limit, and this will set up so you can only drag it out so far, and you can still move your mouse, which in a later video we can change it around to be properly set up for mobile controls, but just for this one we're making it PC. So you can still move the mouse position, but the actual image of the projectile will stay in a specific limit or in a specific place. So this will be set up a bit later on, so we won't use this stretch limit just for a little bit, but it's still good to declare it straight away. Right, up here. So the next one, or the next two, will be our line renderers. So first one I'm going to call front sling. Just put capital S there. And then the second one we'll call back sling. These are our line renderers. So what I want to do to start with is create the function that's going to draw the slings. So I'm going to call this draw. I say slings, although it's just one sling because it's just one piece of elastic in real life. But oops, clicking the wrong button there. To draw slings there. But yeah, so you can just call it draw a sling rather than draw slings. But I don't know. I just keep saying slings because we are making it as if it's two different objects, but it will obviously be just one in reality. But anyway, so what we want to do first of all is set our starting position for our front sling. So to do this, we do front sling.set position, and the first position, or 0, as you may notice it says here integer index. So it's going to create basically an index of positions, and then it's vector-free position. So we won't be using the Z, but for this it declares it as a Z, X, Y, and Z. So it's a 2D game, we'll just use X and Y, but it requires a vector-free position. But it's very easily done, because we do front sling dot transform dot position. Now, as you may know, or you may have noticed, the actual line renderers don't come with a transform object, so it inherits the transform dot position of the object it is attached to. So for this case, it's attached to the front sling, so it'll inherit the transform dot position. And as I said before, the transform dot position is the pivot point, so that's why we change it so it draws it there. We'll do the same for the back sling now, so set position, not set width. Then same again, we're using the first point or the 0 point. Transform dot position. Now, what we'll do as well, we'll set up the sorting order. The sorting layer sort of thing. Sorting order. So the front one is what do we do it as now? I think 0, 1, 2, 3. So it should be at 3, and then the back one will be at 1. because I think we put the projectile at 2. I'll have to check that. So we'll take a note of this now. This is basically the sorting layer that we decided will be the front sling and the back sling. So whatever your projectile is, the front sling is +1 and the back sling is -1. Hope that makes sense. And that's it. That's all we do for the draw and sling function. Now, if you were to run this, you won't see anything because to draw a line, you need 2 points, and we've only done 0.1 here. We'll do the second point in an update for the draw slings, but we'll do that a bit later on because there's certain things that we want to set up first, and then I can explain it as we go along. So in the start function, we just want to call our draw sling, not detour, whatever that is. Call our draw sling function, and then, like I said, that's it for now for the drawing. But we will do an update function as well, but we won't do that just yet. So we'll start working now on the dragging, so the ability to click it and pull it around and drag. After we've done a bit of that, once we set certain things up, that's where it'll become important then to sort out how to draw the line exactly, to put the second point on the line, should I say. So we start off now. Well, we carry on with declaring 2 private objects. We make them private, although one of them we could make it public and drag it in, but it's a lot easier to make it private and do it within the script, just in case you ever forget or you change the object of which the script is attached to or the certain components. The first one we go for is a private spring joint 2D. So I explained the spring joints and we set one up in the previous video. So let's call it spring joint. And then the next one will be a private transform, I believe it's capital T. And this will be, what should we call it, slingshot. It'll be the transform of our sling or slingshot. So we'll just call it slingshot. Just delete that to get back some space. So I don't need that, do I? You can keep your comment in if you want. It's just I'm getting rid of it. So this is now where we're going to use the awake function. Although we are using the start function as well, I should have mentioned in, I think it was the breakout tutorial, that the awake function just works that bit before the start function sort of thing. I explained it better in the other series. So in the awake function, we're going to get our spring joint, and this will be equal to get component. Now before I carry on, the get component part, rather than writing something dot get component, we'll just go straight away for a get component. So this will now, the something dot part where we get the reference, it automatically takes what the script is attached to if we don't declare something else, and that's what we want. We've added the spring joint to our projectile, the script is to the projectile, so it'll just get the component, and then the component we're looking for is spring joint 2D. Make sure it's 2D as well, don't put a 3D one in. And then, just like in the breakout series, I kept forgetting to put the parenthesis, so make sure you do that because it is a function, so you call in the get component function. And then the slingshot equals awesomeness dot awesome. It doesn't really equal that. It equals your spring joint. Then you go for dot connected body. So the connected body of the spring joint means, if you remember when we set the spring joint up and we essentially set its target to be the first sling, or was it the first sling, the second sling, or the back sling, I should say. So the slingshot, what should we call it? The essential backbone of the slingshot is the back piece, the main piece. So yeah, you go dot connected body, then dot transform. So that now takes the transform component of the connected body, which is why it's a private transform, because we'll use this a bit later on. And then we'll go further down here now. We're going to make a new void, and well, we'll make 2. One of them is OnMouseDown. Just open that and then close that. Nope. Use curlies, not the squares. And the other one is OnMouseUp. Actually, before we do this, it would probably help if we add something. We do want to add as well a bool, which I mentioned would be they are true and false. So we'll just call this clicked. Just a private one, we don't need to change it in the inspector or access it from anything else. So we're back down here now, so that OnMouseDown. I've got over my my obsessiveness about the curly bracket not going because for some reason it messes up and resets itself. So yeah, I've accepted that now, just to point that out. So OnMouseDown, we want to learn to spell. Take our spring joint and then we go dot enabled equals false. So what this is doing is it's turning off the spring joint. So on mouse down and on mouse up. Imagine when you click the mouse, you've got the mouse key is down, and then so you're holding down. Sorry, not just click. So you're holding down, and then when you release, that's the on mouse up. Now, don't get confused with the fact that if you haven't clicked anything, the mouse button is up. That's not how it works. You have to click it down first to register it as down, and then release it for it to go up to register it as up. Because it is already up if you don't click. So I understand some people may think it is that. Then you want to go clicked equals true. Let me. So that's the bool we just set up there. And then if the mouse is up, we'll enable the spring joint. We'll go enables equals true. And this bit I may have forgotten to set up in the actual video, but we go for rigid body 2D, then dot is kinematic. Why are you not accepting that? Is it a lowercase one? Why do you not accept is kinematic? Or maybe they've changed it. Okay, I'll carry on. Just remember that that's red for some reason. It should be inheriting the rigid body 2D of our projectile. So we'll leave that for now, just in case something else is missing. I'll have a quick check. And then I'll also put clicked equals false. So I'll just save that for now. I'll drop back to Unity to see why that's kicking up a fuss as it loads in. Project control scripts or assemblers. Aha, yeah, so they changed it. It's a bit obsolete. So yeah, I made it back up, go ahead, whatever. So if you get that then, so just go back to Unity, it'll offer to do an update and we'll see what happens when it changes it. So if you notice that up there, it's gone now. So let's have a look what it's done. Right, yeah. So it just wants you to use get component. So if I open this back up now, yeah, fair enough. I thought I could still get away with that. I keep doing it. I think it's just the transform you can do that with now. So if you have seen the breakout series, there was a point where I just wrote transform rather than get component transform. They seem to have got rid of rigid body now. So what you do there, just in case you missed that or whatever, or if I've edited it out and we just come back now, make sure you write get component rigid body 2D instead of just rigid body 2D because it doesn't like it anymore. Okay, so what we want to do next is we want to create our drag function. So you can declare it here, or we can call it here. It doesn't quite exist yet, so it should go red, and it's just done draw sling. I want to call it drag, not draw anyway. So yeah, let's go with drag, and then down here we'll go void drag, and then that'll go blue there. And this is now going to be setting up for our dragging of the projectile. So what we want to do is we're going to make a vector free, even though it's a 2D game. Again, we're using vector frees, and that's going to get the mouse position. So the void update of drag. Oh, I'll change the update section afterwards because otherwise it's just going to constantly do this, and you actually want to make sure you check if the click is on, but we'll do that in a minute. So, like I said, we're going to get a vector free, and that's going to get the mouse position. So once you've clicked, it's going to now find out where the mouse is, and it's going to put we're going to put the Z position back to 0, and then it's going to get the transform.position of our projectile. So it'll probably be worth putting get component transform rather than just transform, but we'll test it out, see if that one still works. Because it should do, I'm pretty sure it works. And then it'll change the position of our ball to suit the mouse. So first of all, we'll change this to an if, and then if clicked. So you could write if clicked is true or whatever you want it to do, but you can just write if clicked because it automatically decides if it's true, if it's correct, if it's active, if it's positive, stuff like that. So if you don't declare anything, it looks for the good. And then the drag function down here. The first thing we want to do then, like I said, we want to make a vector free, and we'll call this our mouse position. And this will be equal to our camera.main. You may remember this from the old series. If you've not watched the old series, then go watch it because we do screen to world point a few times. But what this is doing, it's looking through our Unity project for a camera, and then it's looking if it's tagged as the main camera. That's why when you start a new project, you automatically have a main camera. And if you delete your camera and you just add a camera, it automatically puts it as your main camera. It's your first camera, it's the main camera. And then we'll use that function from the other, the other series. It's the screen to world point. So I tried to explain it in that last one. So jump back to that series if you want to know. What I could do as well. First of all, we'll go input dot mouse position there, which is predefined. So yeah, what I could do, if you wanted to, I could put just videos together explaining the pieces or the parts of C#, like explaining screen to world point, or explaining what a bool is, explaining variables, different functions, all sorts of things. You know, I could put a series together just on that. So back to what this is though. So what we've done, we've got a mouse position now, and this is equal to the camera.main.screen to world point. So without explaining it, it's going to be hard to explain. And then the import.mouse position. So basically, it's going to get, once you've clicked your mouse, you're going to activate drag, and then it's going to give us a vector-free position of where your mouse is. And then we're going to go for our mouse position .z and equal that to 0 because we want the mouse position to be at 0. And then the transform dot position, yeah, this one still works, weird, transform dot position equals mouse position. So the transform dot position of this object, of the projectile, so we did do it up here as well, get component, yeah, no, get component, okay, so transform dot position of our projectile is now equal to mouse. So if you want some clarification, you could put get component and then transform, and then it'd be a bit messy to do it here, so you're probably doing it up here, get component blah blah blah, and then just referencing it. But since the transform.position still works, it's still active, maybe in later updates they will cut it out, but well, we shall see. So in theory now, I've just saved it, so in theory now you could actually play test it and be able to drag the projectile around. Which reminds me as well, on the assets I've changed it so it's got a point filter, which I might put back to bilinear, and you may see why I've got maximize on play, click play, let it load in. In theory, you should be able to click on your projectile now, just move it around. You won't see the line renderer work, not really much will work yet, we've not finished. I'm just trying to give you an example now. I'm using some weird dodgy mouse as well, but it's okay. But of course, it's taking a while to load. There we go. So yeah, you can drag this around it's not attached to anything, even though it's got a spring joint. It's not attached, and you can literally just like push everything around, destroy the structures, win the level. You know, like I said, once you hit the structures well, not much is going to happen that we want to happen. Like the TNT doesn't explode, the enemies don't die, things like that, because we've not got it set up how we want, and also we can't follow our projectile, things like that. They just let go, and then its spring joint is activated. It comes back to its catapult. So, like I said, we're not finished, and the variable front sling has not been assigned because we're not done. But yeah, you could test it out and see that it's starting to work. So, first of all, we want to now sort of look at setting it up so we use that stretch limit now. So if you pull your if you drag the projectile, it'll only move a certain amount to avoid what we've just done now. So what we'll do is go to declarations, and I hope you understand what raycasts are, because we're going to use them, sort of. I'm going to make a new one called mouse ray, and then in our awake function, we're going to go to mouse ray with a R and R. Mouse ray equals new ray. Can I not say ray? Ray, not new. Okay, forget it. A new ray, and then this will be our slingshot dot position. So the slingshot is the transform that we included, and then we changed it to the spring joint dot connected body, and then give it a vector 3. I'm going to put dot 0. This means we're giving it no direction. Which actually, let me just quickly write something. Let's just write new ray. I'm hoping, yeah. So the vector 3 origin, so telling you where it starts, which is this mouse ray starts our slingshot dot position, which, like I said, is where we put the pivot point of our slingshot. And bear in mind that it's slingshot. It'll be the first slingshot, the back slingshot, the one that our projectile has attached its spring to. And the direction, we'll set the direction in a minute, because otherwise, if we start declaring direction, say, oh, it's going to go over there, it's going to go, it's not going to work the way we want it to be. So we put vector 3.0 for its direction. Oops. There we go. Okay. So as well, now we're going to use the stretch limit. So what I'll do though is I'll create a new float, and that'll be the what's it called? The squared equivalent of the stretch limit we've got. So our stretch limit at the moment is 3F. It's a public float because we may change it to 5, we may change it to 6, and we can do that. So what we'll do is we'll create a new float, and we'll just call it something like, just call it stretch limit 2, it doesn't really matter. And then we'll declare that to be stretch limit, declare it to be equal to stretch limit times stretch limit. Now, if we were confident that we were going to have our stretch limit at 3, then you could just create one up here and just say stretch limit 2 equals 9. Oh yeah, pardon me. Because that's what squared 3 is. 3 times 3 is 9. So yeah, let me just remember what I was doing now. So I want to create now a private float, a bit of activity outside, and like I said, I can just call it stretch limit 2, or I'll just call it stretch limit 2. But you can call it whatever you want. You can call it stretch limit SQR, to say squared, anything like that. It's completely up to you. And down here in the awake, like we've done the mouse ray, we'll basically, like I said, we'll set it up to be equal to stretch limit times stretch limit. I don't actually know. I'd imagine there would be a function that basically times two things together. I don't know. I'll see if I can figure it out and I'll change it. I'll edit the video or something. But yeah, so we set up our stretch limit to stretch limit 2. Stretch limit 2, stretch. Then go down to the drag. Then before we change the input, before we change the mouse position.z, I want to add a couple of things. So I'm going to create a vector 2 now, and this I'll call it sling to mouse, because this is basically taking the position of the sling to where the mouse is. This is where we're going to create our direction, and it's better explained visually, so I'll wait until I've done this bit and then try and show you. So vector 2 sling to mouse, this is going to be equal to mouse position, then minus our slingshot dot position. Okay, so again, it's not going to do anything just yet. You're not going to be able to look at anything, but it's starting to come along. So you go if the sling to mouse, not slingshot, if sling to mouse dot, is it squared? Yeah, squared magnitude. Pardon me. I'm not sure which one to use. I don't think it makes a difference when you use them. So if the squared magnitude, this is where we're now starting to what's it called? Starting to utilize our limit. So our stretch limit, when we set it up to be 3. Right. Sorry. It's better, like I said, it's better explained visually. So I'll just carry on with this and sort of try and explain as I go. So we set it as if sling to mouse dot squared magnitude is more than our stretch limit 2, so which is our squared version of our stretch limit. Which one thing to point out is when you're using the magnitude and you're trying to compare magnitudes, it's always better to compare as squared version rather than the original number. It's more efficient, I think people would say. So if it is, then we want to go to our mouse ray, and the dot direction is going to be equal to the sling to mouse, which is what we just set up here, which I'll explain visually because words just don't do me any justice. Don't know where I've lost the cursor there. I just keep hitting random buttons over it. I'm not used to this now for some reason. Right, yeah, so then change our mouse position. Although the mouse itself won't work, but the registered mouse position will then be equal to mouse ray dot get point. This is important. It returns a point at distance units along the ray. Again, I'll explain visually. And the point we're going to get is our stretch limit. And then save this, and I'll go back. Let's see now. I'm sure. I'm just going to quick check my notes. The next one we're going to start doing this with the last two. This is where we start letting it go. That'll be our updates. Yeah. So this now should have captured our limit. I may have missed something out, so I'll check. It's always good to stop in segments and have a look, see if you've missed anything, any errors, rather than do the entire script and then go, oh, it's not worked. So again, the variable front sling of projectile has not been assigned. What you can do, just for good fun, if you go to projectile, you see you've got front sling and back sling. So open up the slingshot. The front sling is here, so drag that to the front sling, and the back arm is to the back sling. You know, just do that. That sort of works. Click on play. In theory now, it should be the projectile should now be stuck. Right, you see how it's setting up this line renderer. Ignore that because we've not set up the update. But if you see, you can't drag any further than this. You can drag in between, but you can't move past your limit. And then you let go and it's just swings back to where we've set up the origin of the spring joint, and then I can't even grab it now, it's going too quick. It's going to slow down. Well, it is slowing down. There you go. So yeah, like I say, if just go over here as well, stretch limit, you could put that to be 10. Like I said, you can change. That's why I made it public, to make sure we're happy what it is. I'll just click play again. So now the stretch limit is out here. One thing to do when considering it, obviously, you know, you don't want to go anywhere past this because this is just not, and then you've no idea where your strict limit. So it's about there, which looks like it'd be about here perhaps. Yeah. But yeah, so maybe, you know, 9 if you wanted to do the extreme of the screen, but also consider that, you know, you don't want to do this and then let it go because it's just not going to work. Because when we let go of our spring joint, you're just going to bounce. The reason this is good actually is it's an edge collider, so it will go through the edge collider. But if you've put a box collider around this, it'll hit the box collider, so you'll be able to drag it through, no problem. Then you let go, and it'll hit the box collider and just come down here, and you're done. It's finished. So you have to make sure you be aware of that. So putting it like 3 isn't too bad, and then just, you know, it flings along. Like I said, ignore the line renderer because we've not properly set up line 0.1 of our line renderer. Just put that back to 3. I mean, you can try it 4 if you wanted. We'll just save this and go back to our script because, like I said, now this bit is the releasing. So once you've let go of the drag, we're going to snap our line renderer and go. Or I'll break it up into 2 parts again to sort of give you a perspective of the pieces of it. So this first bit, I'll just quick check my notes. I'm sure the next bit is just right. Yeah, so that's completely just Sling's update, isn't it? Yeah. Yep. Awesome. Okay. So just this one piece here now, it's going to go into our update function over here. And we're going to go if what do we call it? Spring joint. Yep. If spring joint is not null, so if it's still here, open our curlies. Then what we want to do is we want to check now if we so we've got to go get component again. Right, okay, I'm going to write this out again and then okay, so just ignore this a second. Just comment that out. Where did I put that rigid body before? Oh, it's been a pain. Right, so on mouse up. So this is the rigid body of our projectile. So what I'm going to do is I'm going to make another private object here, and I'm going to call it ProRig. And in the awake function, oh sorry, rigid body 2D there. So it's a private rigid body 2D. In the awake function, I'm going to go ProRig equals, and then get component, just because it's doing it now, rigid body 2D. Okay, so from now on we'll use ProRig. So down here somewhere, on mouse up, we'll just change this completely now to be ProRig.isKinematic equals false. And now over here, get rid of these. So if ProRig is kinematic, is not kinematic, sorry, because I've got the not symbol. What else? I'm going to check against something as well. I don't think now. So if the rigid body is not kinematic, and oh right, it old velocity. Okay, so close it off. I'll just open them. What I want to declare, another thing up here. I'm going to make, I think it's a float. No, it's not a float, is it? What would it be? We're measuring the velocity, so it's the go for a vector 2. Pretty sure it's vector 2, not vector 3. So private vector 2, and we'll call this old velocity. And we don't have to do anything just yet because we'll declare it as we go along. So go back down to our update function. So inside here, hang on, I've not properly declared it, have I? Oh, sorry, just clicking loads of things. Whoa, don't do that. Sorry about that. I held down shift there, so I looked at my notes. I've jumbled something up here because I'm sure I'm supposed to declare that first. No, sorry, misunderstood my notes here. I just scribbled some stuff down, so I'm a bit confused. So anyway, so inside the update function, if it's clicked, then we do our drag. If the spring joint is not null, so if it is still there, and then you want to go if the pro rig, so that is short for projectile rigid body, by the way. I've not said that. As you can see here, the pro rig equals get component rigid body 2D. Same as the spring joint is equal to get component spring joint 2D. That's just like I said, the get component in itself without any reference in front of it. Then it's getting the component of what our script is attached to. So pro rig, when our projectile's rigid body dot is kinematic is false because we've got the exclamation mark here, which means the reverse or the inverted, and we're checking old velocity dot squared magnitude is more than rigid body 2D, so more than our pro rig dot velocity. Did we put 2D? Yeah, we put 2D. Okay, so our pro rig dot velocity, then also dot square magnitude. Okay, so like I said, we're now comparing. No, we compare magnitudes, but we're using square magnitudes because that's more efficient to compare, and then we're going to compare the velocities. Now we've set up old velocity above, but we've not given it any values yet, so that will come to that. Don't be worried. But if our old velocity, so the velocity that we recorded of the last stage, the last frame, if it's more than the current velocity, then what we want to do is destroy. Yeah, destroy our spring joint, and then this is where we start to set it up now. So go for pro rig dot velocity. Then we'll make that equal what old velocity is. That should be the end of that one. Then let's think. So if you have not clicked, this is where it comes in. So you can probably put this whole piece above, but I didn't for some reason. If you haven't clicked, then old velocity is equal to our pro rig dot velocity. There you go. So you can probably put that above. Because we use old velocity here, obviously make sure I just close it off with semicolon. So we're checking now if you have clicked. So whoa, hang on, what have I done? If you haven't clicked, right, let's drop you back there. See, this is why I prefer my own formatting, so I can make sense of it a bit more. So yeah, we'll save this now. I'm pretty sure it's going to run correct. So we're just going to drag this in here. I'll not drag it in, ignore that comment there. Click on play, get it going. Again, it probably takes a few seconds to load, so I may try to eat, nope, can't, I was going to eat a cookie. So now in theory, now you can drag this, and if you let go, it fires. And the camera doesn't follow it, there's no second charge, the line render is still not set up, so you just have to stop it and do it again. Now this is where you come in as well, you'll edit the mass and stuff like that, edit the size of it. Let's see, we'll go down there, see if we can get something, knock them out. So we're not really doing much, and obviously the buildings are set up in a specific way, so we increase the mass and things like that. But we'll come into that in a later video. And like I said, I'll probably want to change the pixels per unit, but since we're writing this, we're on a bit of a roll, so I want to keep them going. So the next thing we want to do will be the slings update. So we can put this in here. Well, we'll drop it into our... Right, so which one's this one belongs to? That belongs to that one, that one belongs to that one. So I've dropped that one along there just so it's a bit clearer. This one belongs to this one belongs to this one. So I think inside there we want to do our what's it called? Our draw sling update. Okay. Now it doesn't exist because we've not made it. So drop underneath your draw slings. Call it draw sling update. Do the parenthesis and open and close that. Now I may have put that in the wrong place just because I've not set up the curly brackets the way I want them to be. So yeah. So what we want to do, we'll start with we'll get our position from the projectile and the front sling. So what did I say I was going to explain before now visually? Can't remember now, but I'll explain it all as we finish. So what we're going to do, I'm going to start off making a vector 2, and I'll call this sling to projectile. Projectile, nearly forgot to spell them. And this will be equal to, right, we'll do the transformed up position, that one still works. Equal to transformed up position minus our front sling dot transform dot position. So understand a bit of basic maths. It's taking one position minus another position, so you sort of split the difference or get the difference. Okay. What are we going to use? Okay, probably helps if we declare array here as well. So another one, just like this one. We're also going to make another array with 0 direction again. So that's what I was going to explain before, is the arrays. So I'll explain this better after I've finished writing this part of the script, because this will be the end of the script here. So I can throw in a bit of the explanation and then the video will end. So don't celebrate too soon though, because we've still got a bit of script to do. So a new array, and we'll call this one a bit long. Front sling to projectile, just to P. Front sling to P will do. That'll do for now. So we'll drop back down to wherever it was we were in our slings update or our draw slings update. Well, maybe it would help if you actually declare what your array is as well. Like I said, it's going to be just like the other one. We'll just set its position and give it no direction. So I'll just try and jump through this. Equals a new array, not a new rat. And then the position for this one though, it's going to be from our front sling, not the whole slingshot. So still transformed up position. And then, like I said, we're going to go for vector 3.0, so just neutralizes it, gives it absolutely no direction at all. Then we'll drop down to our sling update here. And then just set our front sling to P dot direction to be our sling to slong. That was very childish, I apologise. Sling to projectile there. Just save that as we go along now. What we're going to do as well, I'm just going to tell you how it is and then I'll explain afterwards. We're going to go and declare what is known as a radius. If you know your maths, you know radius, diameters, circumference, stuff like that. We want our radius. So we'll go for another private float, and I'll call this pro rad because we're pro radicalists. It's not even funny, I don't know why I said that. In the await function, we want to. This is where I was mentioning before. We're using a circle collider here. So now this is important for you to set it up so you use the correct collider. If you're not using circle, if you're not using circle collider won't work for you. Just call it circle. But this is going to be equal to collider 2D. So it's equal to get component collider 2D as a circle collider. Is that right? Is that correct? I think that's right. I'm used to writing it just where you just like declare it without having to get a component. So they've changed that stuff around. It is actually an old update as well. It still catches me out on some things. I've not tried to make this game for a while. Right. So what you're writing here is Circle Collider 2D. Then you're calling it Circle. So you're declaring an object of Circle Collider 2D, and it's equal to. Then you're getting the component of the collider, which is attached to your object. Like I said, this specific bit is only going to work as a Circle Collider. With Circle Collider. So you get this component and then you declare it as a Circle Collider 2D. The reason we're doing the Circle Collider is because we want a radius, because it's going to be a circle and we want to get the radius. So what we do next, our pro rad is equal to circle.radius. Like I said, it works as a circle with Circle Colliders. So now that we've got this, we're going to go back to our Sling updates. I do write them there. Draw Sling update. And then we're going to make a new vector 3. And we're going to just call this point. This is going to be our second point of our line renderers. So vector 3 point equals our front sling to P. And then you want to get point, like we did earlier. Not get type, get point. And then the point you want to get is sling to projectile. Then you would use the magnitude, just a normal magnitude now because you're not comparing anything. Then plus pro rad, so the radius that we've just made or declared. And then what we want to do for the front sling and the back sling. I was going to try and do both at the same time then. Front sling dot set position. And then the position we're going to set is position 1. And then point, the point that we've just made there. Set position 1, and the point that we've just made there. Now the only thing that may go wrong is where I've placed it here, because I'm a bit confused with my curly brackets. So we'll save it up here, and I'll just quickly test it, make sure it works. And then if it does, I'll jump back to the script. So the raise before. Ooh. Sure, it's supposed to be Collider 2D as well. I apologise. I've been mentioning it so many times. Make sure you put 2D. Make sure you put 2D. It's got to be 2D, otherwise it won't work. Drop it in, save it. There's no errors, so I'll just quickly try and play and just fling it along, see if it works. If it does, then great. If it doesn't, it doesn't there. It's a line renderer we're trying to do now. Most of it works. It gets rid of the line renderer. So it's the positioning of this. Let me just check this again. So our update function here. We'll draw some update. Just gonna. Right. So this one is what this one. So underneath that one, so it's outside of there, but it's before this one. So what's this one? So if the spring joint is not, so the spring joint is still active inside this one. We're going to run these and we're going to do our update because we're going to drag it. Okay, this should now work. Like I said, I used to format it myself where I just drop that down, drop the curly bracket down so I can just easily point out that one's that one there, that one, that one. For some reason, MonoDevelop auto formats things and it just made in, so I've just decided to go back to the other way. There we go. Yeah. So you can see now the line renderer now change its position to where it needs to be, and then once you let it go, it kills itself. Well, I shouldn't say that. It removes itself. It undraws. It rubs itself out. Whatever. So yeah, I'm just moving now to try and explain the raise. So the reason I had to get a radius is if you look at the spring joint, it starts here in the origin point and it pulls itself to this origin point here. So when we draw our line renderer, it draws it from that point to this point now. So we've changed that where we put the get point sling to projectile. So that ray is this line, so we're starting it at our sling to projectile position. Like I said, we put transform.position minus the front sling dot transform dot position. So this is your front sling, so that's your position there, will be that origin point. So sling to projectile is essentially this green line along here now to the transform dot position of this object. So when we draw our line renderer and we set it up where we put front sling to p dot get point sling to projectile, which like I said we've just declared as that line dot magnitude, then it will draw a line from here to the middle of this. So we made the radius, so we got the radius of this circle, which is, as you know, it's half the diameter or circumference, half diameter. So we've added half the diameter, so we added the radius, so the line renders at the back here now. And we've done the same for the front and the same for the back, and that's how that works. So you can move this around, and as you saw, the lines had rendered themselves. So as you can see, like I said, it's a bit of a long video, trying to explain everything as it goes along. The plans for the next one: set up the camera so we can move it along. Also, in Angry Bird games, you can like squeeze this, sort of squeeze the screen to change the zoom and stuff like that. So I'll try and show you a camera option to sort of change its view to make this fit in, sort of thing. May or may not work depending on how I set up the background and stuff, but we'll see that in the next video. We'll also start coding some sort of like health for these to tell us when to kill them and change the states and stuff, destroying the actual, what they're called, obstacles pieces, and blowing up TNT, stuff like that. So coding for all the structures we'll do in the next one. So yeah, that's about it really. So I'm going to go back to the code, the script here. Zoom in a bit there, that should be clear enough. So now you've got the using Unity to the awake function. So I'll just leave it there. If you want to click pause to now copy it down, now's your chance. So now I'm going to scroll down to underneath the awake section. Directly now we've got the void start, and we drop down to the end of draw sling. So if you want to pause, go ahead. And then one second. I've now gone down to where underneath the draw sling to the draw sling update, all the way down to the bottom of drag, and it ends here. That's the end of your script. So if you want to pause, now go ahead. And then just to show you, you just need one more curly bracket which will end the entire script at the bottom there. So that's that. I just did that bit, like I said, just in case you were trying to follow it along by pen and paper. I know some people that do that when they do tutorials. They'll try and write it out, and then they'll write the start function, and then something gets added above that, and it's like, oh no, it's in the way, and then they just mess up the notes. So that's that. That's why I've done that. Yeah, so that's it for this video. Like I said, it's a bit of a long video trying to explain everything to you. Let me know in comments if you do want me to do a video sort of just explaining what C# is and how it works with Unity. So there I could explain every single piece here. You've got the raycast, the rays, the transforms, the spring joints, bools, floats. We haven't used any integers here, but you know, if you want me to do videos based on just C# and not actually specific to a game, let me know that, and then the videos could be just as long, but at least you're learning what each specific thing is rather than me trying to explain and then maybe making it worse. So yeah, let me know in the comments what you think. Give the video a thumbs up if you liked it. Drop a comment with some feedback. I know it's a bit of a long video, so thank you for sticking with it all. And subscribe, yeah, I forgot to say that. Make sure, well, you don't have to subscribe, but I mean, I could send assassins out to you or something. I don't know. I'll blackmail you somehow with something if you don't subscribe. So you might as well subscribe, because if you subscribe, then you'll be able to watch the video of me blackmailing you with something if you don't subscribe, which maybe I won't need to update that video because you did subscribe, so then the video wouldn't really exist because I'd never have to record it because you subscribed, which means you would have subscribed for no reason apart from to see other tutorials. So give it a go, subscribe, yeah, that's it really. So yeah, thanks for watching and have a good day, and I'll see you in the next video.